Not all the amount of precipitation goes to direct runoff used for any hydrologic projects we design. There is also base flow, but how do we distinguish one from the other? Learn it here in hydrology. When we draw a hydrograph, there will always be two parts of the water. The one on top is the direct runoff, which we can use to run our water projects. And the one at the bottom is the base flow, which is the amount of water underneath the grade replenishing streams and rivers. Now let's discuss how to separate direct runoff from the base flow. Say we have a hydrograph. This is the plot of time versus the discharge. The first point on the curve is the start of the runoff. Another point is also known as the peak discharge. There is also a third point after the peak, which marks the end of the runoff. By identifying the start and end of the runoff, we can separate the base flow with a connecting line. This is the concept of single line method. Using single line method, let's determine the base flow and direct runoff per hour given a dataset. For this example, we assume the starting and ending points of the runoff of the 3rd and 11th hours. The first thing to do is to draw the hydrograph. With 13 hours covered in the dataset, the x-axis should have at least 13 scales to mark the hours. The y-axis is the discharge, and having the highest value as 380, we work on 400 QMEX with 50 QMEX intervals. Now we can readily draw intersections, such as 200 QMEX at the first hour, 170 QMEX for the second hour. The third hour marks 150 QMEX. The fourth hour has 220 QMEX. 350 QMEX is at the fifth hour, with the highest discharge of 380 QMEX at the sixth hour. The seventh hour has 345 QMEX, with 310 QMEX on the eighth hour. The ninth hour shows 250 QMEX and 175 for the 10th hour. The last 3 hours draw 105, 85, and 65 QMEX for the 11th, 12th, and 13th hours. These points are then connected to have the flashy curve. The premise already identified the start of runoff being the 3rd hour, and the end of runoff is at the 11th hour. So these 2 points are connected by a straight line. We then create a triangle with a separator. So let's zoom this in. One vertex contains 150 QMEX, and the other has 105 QMEX mark. The horizontal span of the triangle is 8 hours. This is from the 3rd to the 11th hours from the dataset. Then the difference from the discharge is 150 minus 105 or 45 QMEX. The base flow is those values at the separator or the bottom of the triangle's line. Let's then compute for the base flow. This is computed starting at the 3rd hour. At this point, note that the base flow is at exactly 150 QMEX, which means the base flow is also 150 QMEX. The succeeding hour then can be computed by using similar triangles or ratio and proportion. Taking the small triangle, there is y is to 1 hour, as the total triangle has 45 QMEX is to 8 hours. Y is then 5.625 QMEX. Using the upper level of 150 QMEX, We compute for the base flow at the 4th hour as 150 minus 5.625, giving 144.375 cumex. The base flow for hour 5 then uses 2 hours in the ratio and proportion, where y is computed as 11.25 cumex. The base flow at this hour is then 150 minus 11.25, which gives 138.75 cumex. For the 6th hour, the ratio and proportion uses y is to 3 as 45 is to 8, where y is computed as 16.875 cumex. Base flow at hour 6 is then 150 minus 16.875, which is 133.125 cumex. The 7th hour then uses the ratio of y is to 4 hours as 45 cumex is to 8 hours. Y is then 22.5. The 7th base flow is 150 minus 22.5, which is 127.5 cumex. The next hour then is proportioned as y is to 5 as 45 cumex is to 8 hours, where y is computed as 28.125 cumex. The base flow at the 8th hour is then 150 less 28.125, which is 121.875 cumex. For the 9th hour, the proportion included is y is to 6 as 45 is to 8. So y is determined as 33.75. Then base flow at the 9th hour is 150 minus 33.75, which is 116.25 cumex. The 10th hour contains a proportion of y is to 7 as 45 is to 8, where y results to 39.375. And base flow at this hour is 150 minus 39.375, which is 110.625 cumex. Then at the 11th hour, or the end of the runoff, the base flow takes the exact point, giving 105 cumex. The next requirement to answer is the direct runoff per hour. This is the amount of water that can be used as runoff in each hour. At the start of the runoff, the discharge is fully taken as base flow, so the DRH for the 3rd hour is 0. For the next hour, the DRH is then the coordinate of 220 cumex less the computed base flow of 144.375, which gives a DRH of 75.625 cumex. Yet the 5th hour, the DRH is then computed as the discharge of 350 less the base flow of 138.75, giving 211.25 cumex. For the 6th hour, the DRH is then 380 cumex less the base flow of 133.125, which gives 246.875 cumex. Next is 345 minus 127.5 cumex for the 7th hour. This results to 217.5 DRH. On the 8th hour, the DRH is computed as the difference between the discharge of 310 and the base flow of 121.875, giving 188.125 cumex. The 9th hour has a DRH solved from 250 minus 116.25, which yields 133.75 cumex. On the 10th hour, the direct runoff per hour is 175 minus 110.625, which is 64.375 cumex. Then lastly, at the 11th hour, all of the discharge is treated as base flow, which means there is zero DRH.